Okay, it seems like we're begun. Gotta remember the routine here. Switch to the video. Okay, it seems like there we go. Working audio and such. Get rid of that. Get rid of that. And I might do some drawing here. So probably a better way to do this. This kill an awful lot of space up here. But I'll worry about that some other time. Probably. Plenty of space for drawing. But we'll do something besides drawing first, which is subscriptions. Okay, so the CNPS Saturday conference thing really wasn't too bad. The real problem is they got to get over these technical things. Way too much feedback, background noises. I mean, this is just stuff, the ABCs of, kind of live broadcast. You just kind of, you have to, test. And you have to, make sure people don't have their speakers too loud, or they're wearing headphones if their speakers are loud. I mean, feedback's pretty easy to get rid of, all that kind of, anyway. So it's 2 hours that are pretty obnoxious to the senses because their, quality kind of sucks, but the content didn't entirely suck in terms of the conversation. And the only thing it does illustrate, though, is as soon as you get too many people into a conversation, more than 3-ish or so, it just doesn't stay on subject, kind of migrates a little bit too much, and it gets in tangents and other stuff. And I think it, degrades as a conversation. But 2 sometimes isn't enough people because you don't have anybody fact-checking, the 2 people kind of thing. But anyway, there's sort of a way to do it, I think, that's best. And they're not quite there yet. And it's hard to achieve. So, but first you got to do just get the preliminary stuff right of having it acceptably listen, where you can just, and it's not lag and you don't have people talking over each other and all that kind of crap. But anyway, all right. So the subject is, they spent a lot of time on this idea of relativity in the sense of, taken down to the, magnetic electrical kind of realm, where you have this idea of moving things, charges, and the fields they create, and the fact that those things might not be tied to each other directly. It's sort of a conversation a little bit like speculating about if the sun blew up all of a sudden. It would take 8 minutes for us to know it happened. And the gravity effects of the sun were already in the field, so to speak. So it's like we wouldn't know we're free for 8 minutes. Okay. But by the time we know we're free, the explosion reaches us and we're doomed. It's not like in the other realms where you're going to get some subtle warning. The radiation will be the thing that kills you, and it'll be the thing that gets to you first. But like I said, if the sun just disappeared, that would be a whole new scenario. But yeah, it'd be 8 minutes before we would know the sun disappeared. Because it'd be 8 minutes, the light's already on its way here, the photons. So I would argue that in having that kind of a conversation, the first thing you should really establish is, let's have the conversation establishing some premises, which would be anything that moves the speed of light, we'll call it a force. And we'll say that force makes a field. And so the field doesn't exist or mean anything unless it's forcing. It has to have something in it that's going the speed of light. And if it doesn't, it's irrelevant. It doesn't have a substance. It doesn't mean anything. And it might be a way to get around what became their problem, in a sense, was arguments about the existence of ethers, and then arguments about whether the ether has to be made out of something, like water molecules. Like somehow you couldn't have just an ether that is just tension or just the coldness, rubber, solid piece of rubber or something. I mean, the idea that, they want to particularize something called ether And then when you particularize it, though, it doesn't make any sense to give the particles no reality except they can, like they're stuck and all they can do is vibrate in the ether. Like they were as limited as water molecules when you could just as easily make the ether out of sand, that wasn't tied to each other very well. And then you could just as easily make the sand into stuff that moves the speed of light constantly. So, I mean, there's all kinds of variants of how you create this thing called a field, and how it manifests as a force. So, generally speaking, I think the Franklin guy is reasonable, but he seemed to get kind of unreasonable in his declarations about what ether has to be. And especially when he was trying to assert some point about charge. Somehow charge, unlike the sun disappearing, if I made a charge disappear, it doesn't have any effects in a field. The charge isn't emanating something that moves the speed of light. When I think it's pretty hard evidence that that's exactly what it's doing, that electrons do emanate a force that is communicated to other objects at the speed of light, and therefore it's just as real as photons. And just like photons on their way, once a star billions of light years away lets some light loose, it can't take it back. The star can blow up, and it doesn't matter. The photons will still travel. They're still going to do their thing. They don't care what happened to the source. And electrons are doing the same thing. Whatever they're doing something quite similar to what a sun is doing, in the sense that whether you think it's attractive radiation or repulsive radiation, whether you think it's something that hits or pushes or pulls, the fact is that whatever that thing is, it's in the field, and you can't retract the field. You can't retract the force. Once the force is out, it's gone. It's on its way. It's independent, and it's going to do whatever it's going to do. So, and I thought he was being a little bit pig-headed in obliging everybody to accept his premise that somehow there's some reason to believe that electrons communicate instantaneously with the world, and that somehow whatever they do can be undone just by making the charge disappear. I can make whatever force effect it's had on the environment, which is just like gravity. It goes forever, technically. I mean, technically, too, electrons a billion light years away from each other can technically communicate. And that somehow that communication would stop if I squish one of the charges. I don't think there's anything in the evidence that indicates that's the reality. So, I just don't know whether this, this conversation is going to be premised on things where, it's just not going to be too good for intermediates. Because you're getting into layers of the history and Maxwell and Einstein, and conclusions drawn about ways of saying things. And so it is sort of a semantics argument, complex semantics, because it's almost like the Einstein statement that I find perfectly agreeable, which is that light always moves the speed of light. That light doesn't care about the source, doesn't care about the receiver, doesn't care about it. It functions completely independent. And all that really can change is perception, how you see the light, not what the light is actually doing, how you understand it. But there's only one truth for the photons, kind of thing. That's agreeable. And that's sort of, though, by Einstein's permission almost, that has been perverted into statements about frames, and somehow a strange truth that both perceptions, two conflicting perceptions, can both be accurate, where that can't be true. Yeah. All right. All right. So that's where we'll start. And so let's see. get the comments. So I think I'll do some drawing. I guess I'll see if there are any comments first, get that out of the way. And such. Doesn't look like much here. Okay, and really not much. Coffee tastes like fertilizer. I wonder how true it is that it has any benefits. Yeah, I don't. You have to wonder about everything that's done that's called the research. Whether they just ask people questions, how do you feel? I mean, those answers aren't going to be very scientific. So I don't know what they really have. Everything's correlated. Usually people who smoke have a much higher likelihood of being coffee drinkers. There's lots of things that have associations and ties. So you can find a benefit in something, and it's really not that thing that's the benefit. It's the other thing that's actually creating the benefit. And the two things are just correlated. So it does get a little messy. All right, somebody called 357 maximum, which is bizarre. I mean, it should be 357 magnum, but whatever. Bizarre. You have built a solid foundation of ignorance for yourself. So again, it really wouldn't be an ignorance for myself. It would be a delusion. You could say you built a foundation of delusion. You can't build ignorance by definition. It's a lack of bricks. Okay, it's not wrong bricks. Delusions are wrong bricks. So you're not even smart enough to get that part of this analysis correct. Idiot. Anyway, so too bad it will be too late for you. In what sense? I am perfectly comfortable with me, and I would be perfectly satisfied, I think, in hindsight, even if I found out I was wrong. The fact is, everything I did here was perfectly rational in the sense that this wrong theory creates answers that are even better than Einstein's answers. And there's no woo. There's no magical stuff. There's no dark matter or dark energy coming to the rescue. No, none of that horse shit. So I have nothing to feel bad about because it really looked like a right answer. It did everything right answers are supposed to do, which is fit the evidence and fit it well. So there's not going to be any too late for me. When you yourself realize this, I won't realize this. I've done my work. I've spent years acquiring knowledge on the subject, listening to different college lectures, enduring rather unpleasant entertainment, you could call it, or whatever, consumption. I've consumed information that wasn't fun to watch. And I've had to do a lot of thinking about problems and coming up with solutions to them. Another thing that isn't much fun. So fuck you, turd. You're just a useless turd. Just fuck off with your 357. I'm a 753, fuckhead. Way ahead of you. Twice as big. Anyway. All right. Roasted that masculine. Fuck like a fly on a grill. Yes, like a moth. Like a maggot on a grill. I mean, it didn't stand a chance. Couldn't even fly away. Zzz, pop. Just pop. All right. So comments suck as usual. Disappointing, but that's all you get is crap. People can't make a counter argument. They can't compose anything that's reasonable or logically compelling in some way as a counter argument. Can't provide anything called evidence. Nothing. Just lame as lame could be. Again, just completely encouraging me to think I must have the right answer. If this is the best they can do, then yeah, I'm probably pretty fucking right. All right. So that's probably enough of that. So I guess we'll do some drawing probably. We'll attempt to do some drawing probably. Just really stupid that this program doesn't have a color selector. I just can't believe it doesn't give you the option of just clicking to change the color. So weird. absence of functionality. And considering it does so many other things so well. Quite bizarre. I mean, you can even make transparent PG whatever files and such. You can make animated thingies, and I mean, I haven't even explored all of these functions, but it has a whole bunch of them. But I can't change the color without opening a whole fucking window. It's just retarded. All right, anyway, I'll stop complaining about that, I suppose. I don't know if I really feel like not complaining about it. It's just a pretty big flaw, substantial flaw. Anyway, I mean, I could be wrong. Maybe it's here somewhere, and I just haven't found it. I just haven't found any feature I can open, any function, anything that allows color selection in a simple way. I guess no one had to use this program to explain anything. But anyway, all right, so there's this, I could probably use images. It might have been a better idea, but it doesn't really matter. So you have this idea of two conductors, wires, and, two wires of blue. And if you have the current going in the same direction, okay, in the wires, all right, there's this circumstance that doesn't seem right, which is if these were two magnets pointed the same way, change the color. It's just annoying. It just doesn't, that's just way too much trouble. So if these were two magnets, you could sort of understand they'd have a polarization. And even as wires, you can sort of understand they would have a, so this is only true with DC current too. So this is sort of a giveaway. This is DC, so it's not alternating current. Yeah. Comments. Morning. Hey, morning. Sort of. It's barely. Almost past that now. And it's drizzly, so. But anyway. So the idea is that this looks like these two wires should repel. If they were magnets, you'd say this is repulsion, because you'd have high voltage at one end, plus, let's say, whatever, and they're both plussing at the same end, or they're both minusing at the same end, however you want to look at it. And that's like lining up two magnets with each other, and you would argue that there's got to be more electrons at one end and less electrons at the other end, or some kind of crap like that. And therefore, these two wires should be repulsive. And instead, the two wires attract each other, which should be drawn. Well, I guess I won't bother drawing it in here. Well, I guess I could do it this way, but that's just, that's indicating the wrong thing, what's established is that they move this way. They move towards each other, away from the external world, which doesn't look right, doesn't fit. All right, so and so this is where you get into this argument of a field being created, right? We have this idea that electrons are what's causing this whole thing, right? So the electron somehow, when it moves in a direction, somehow it makes a field in here. So when it's moving, somehow it's making a field. And I would argue that if we think about the electron as the element of charge, it's like we're back to the ping pong paddle thing. So the electron is a paddle, okay? And it's not one of the little balls. The balls are photons. Balls are the things moving the speed of light. So the paddle pushes the balls, so to speak. It reflects them, but if it has a momentum, you can sort of get the idea that it can't add energy to something already moving the speed of light, but what it can do is remove distance. So it can't make something go faster, but it can shorten the distance it has to travel, kind of thing. So that's sort of what movement is. Movement is changing the distance. So if you had two things moving towards each other, two paddles, you could sort of understand that they're not going to make the ball move faster between them, but they will be cutting the distance you know, into less and less distance, which means the same thing, which means the ball will hit the other paddle sooner than it would have. Now, it's not going faster, but it will hit the other paddle sooner. Okay, but it doesn't go faster because there's less distance. So moving charges is changing the distance between charges, and that has more to do with it than the actual movement, I would argue. So the other part that I would say that you can just speculate about what's being secreted. I argue that when an electron is moving, it's secreting a red force. That is the opposite force of what its charge is. So if you move a negative charge, it secretes a positive force. And if you move a positive charge, it secretes a negative force. So you have to keep, you always have to keep, these are the force bits, the little things. Yeah, that's force. And the paddles are, what could you call them? They're the charge elements, but that's really not a perfect word for it. But yeah, they're different. They're matter, and this is force. Matter bit, force bit. And it matters if these charge bit, these matter bits are moving. All right, so I could argue that what's happening here in this scenario, where these things that look like they're the same kind of magnet and they should be repulsive and instead they're attracting, is because they're both pushing in the same direction. That is, the charge is moving in the same, the charges are moving in the same direction, which means the paddles are kind of, they're not creating less distance between each other, and they're both pushing something, you know, they're pushing on each other in a similar manner, but not accomplishing anything. I mean, there's no, let's see, what's a better way to say that? Well, think about it. And let's say if they are electrons and they're secreting, let's say the electrons when they move are in fact secreting a red force, and then there's electrons moving in both of these things, they would both be non-reflective. It's not the right force they're getting hit with. They're getting hit with the force that doesn't create reflections. So what you're really trying to calculate is how much reflection is being created in the wire. And the point I would make is the electrons are, we sort of know that when current goes through a wire, it's going around the outside. The electrons are going around the outside of the conductor. And so they're kind of like the appearance of it. It looks like all black paddle in a sense. Each wire looks like a black paddle, not a red paddle. And both paddles, because they're moving, the electrons are excreting red, which is totally unreflective to the paddles. So neither paddle can feel the force they're producing, and it creates the external pressure, pushes the things together, but you create the low pressure. And it only, this, like again, this only works with DC current. So if you had alternating current going through the wire, you could understand that that would be constantly changing the plus to minus thing, and the force would be traveling between the two wires. And by the time the force went from one wire to the other wire, the phase would have changed, which means the wire would be, say, electron heavy on the outside when the black force was coming, and that would reflect. So now it changes that imbalance, and now there are reflections, and now the two wires will just stay where they are. All right, now for the magnet. So this is where they really, this is the part that gets really, obviously people have a, and I had the same problem before I figured it out, you know, trying to understand this energy argument. All right, so let me just do a new file thing here. Start over and make it fit. All right. All right, so as I've pointed out with gravity, there's no real mechanism to explain where you get the energy from to make the Earth move into the sun. So it's a huge amount of energy. If I had to move the Earth myself, if we had to do it, if we had to keep the Earth in orbit, we'd have to spend a huge amount of oil and resources to make giant engines to push the Earth into its orbit, to push it into a spherical orbit. And we'd realize there's no other way to do it. We'd have to burn something. We'd have to transfer energy from one form to another form, as is traditionally the way you get work done. We'd have to pay the work price. And somehow people have this notion that gravity doesn't have to do that. Gravity is some sort of free thing, free energy. And so they think they can tap into this free energy stream because there's some sort of free energy stream that's outside of what we understand. You don't have to do any nuclear energy, and you don't have to burn any oil, and you don't have to burn candles, or you don't have to convert calories. You don't have to make sugars. You don't have to, you don't have to do anything. No chemistry involved, no physics involved. You just make free energy. And so anyway, people have the same perception about magnets. Somehow we don't have to explain, or regular physics doesn't have to give you an explanation for where the energy comes from, what gets converted to make one magnet fly into the other, or the magnets fly apart. Somehow no engines, no flames, no functional energy in the equation. That's why they call it a virtual photon, the force carrier, because the force is unaccounted for. There's no accounting for the energy the force expresses. And there's a lot of people that are comfortable with that. And I think that's rather revealing, because to me it's so fundamental to a rational theory, is you really do have to find out where the energy comes from. It has to be a mechanical mechanism that produces the energy. Because as we have found out, there is no free lunch. There's no free stream of energy somewhere that we can just stick a flag up and I caught some in my net. The free energy. We know that doesn't exist. People have been trying and trying and trying, and we know it's fail. You will not get it. You will not have it. It does not exist. And you can have things that look free. Like I said, nuclear power looks free, but we do know that the sun has to convert. It has to consume mass to create all that nuclear energy. So it has to take something that was stored previously. The pressure of the atoms, the compression of the atoms is stored energy. And when you uncompress the atoms, you're releasing that stored energy. All right, so I've sort of been over that and over that. I think it's a fairly solid argument that cannot be defeated. What is this? Make some noise, boobilus. I don't know what this. You were my 4 other draft sciencers at. Wow. Okay, we won't remove. We'll just get rid of this guy for eternity. Yes, no hope there. Anyway. Okay. So I think that's probably enough of a premise, right? So this is why I'm trying to emphasize this idea that when we say the word field, when somebody says the word field, I think there should be an obligation to sort of recognize that the field is defined by the fact that it has force in it. So you could almost argue that light is a field of photons. And when something's not emanating photons, there's no field, no force, no field. So that the word field should really be tied to a condition that's active, not a condition that always exists. So when they say something like, well, light's bending this way and bending the 2 fields, as if the fields exist always and that light is somehow vibrating through them. When, again, that's not energy then. I mean, to have energy, you can't just... you have to account for vibrating the field. You don't get out of the obligation to have energy. The rock dropping, okay, is, into a puddle, into a pond. That's the energetic event. You can't just say, I don't need to have an energetic event to move the medium. I can perpetuate the field by just saying perpetuate. No energy required. I don't have to burn anything. I don't have to drop anything. I don't have to create potential and then turn it into kinetic. And you do. So this ether thing doesn't fix anything. Having these, having a dead field that just sits there and waits to be vibrated doesn't solve your energy problem. So I think to really understand, you have to understand that the field carries real energy. There's really something that is emitted. So sort of like what you have to think about it as when you drop the rock, you have to understand that the rock, you don't need all of its energy, but some portion of the rock's energy is now being pushed through the medium, so to speak. The rock sacrifices something real. Okay, it emanates a real force, just like we know that if I was to radiate light, not just reflect light, but to be a sun, I'd have to burn energy to radiate the light. You can't radiate photons for free, and you can't radiate charge for free. All of these forces move the speed of light, indicating they're all the same thing. Gravity, magnetism, electricity, however we want to, the two are the same thing, but anyway. And the nuclear forces, all this stuff moving the speed of light is all the same stuff. And it's stuff moving. And when that stuff exists, then there's a field. When that stuff doesn't exist, turn out the lights, photons, there's no field. There's no photon field when the lights are off. The field only exists when the photons are in the field moving. So now I'd argue that the gravity light never turns off. The cosmic background radiation is always on, like gravity. And so that field, the gravity field, is always on and always full of stuff moving the speed of light. Gravity's always on. There's always stuff hitting you. Gravity stuff. Gravitons, whatever you want to, gravitons. So that world exists. And I've explained how that's Mach gravity. That idea of little particles moving the speed of light. It's Mach gravity, and it duplicates all of the math very, very well. Covers the basics of why things get into circular paths, why things turn spherical, why things move together. It does it all. And so I'm arguing that if you can make that good a model of gravity out of this idea of an active field, an active ether, an ether of a real particle already moving, a photon with energy, okay? And that's what gravity's behaving like. That's why they call it virtual photons in magnetism. It's because they behave just like photons. And that behavior is just like gravity, just like Mach gravity. Mach gravity is essentially particle photons. Photons understood as particles, not waves, causing gravity. And essentially Maxwell's equations effectively describe a very similar Mach gravity, particularized, quantized, radiant force that moves the speed of light and creates a field by existing. All right, now as I've explained, the trick, the gimmick, the eureka thing to figure out is that the magnet doesn't have to account for the energy because the magnet's using exactly the same energy as gravity. It's just filtering gravity. So it's just taking a force that already exists. It's already moving through it. It's already causing it to move towards the earth. It's already causing effects. And it's just taking that, and by merely filtering it, just causing it to disperse in a different way. Okay, so let's just pretend the magnet's down here. The mixed force goes in, black, red, black, red, black, red, and it comes out of the magnet. This is what gravity does when it comes out of a magnet. Now, if it wasn't a magnet, it would just be all mixed, black and red on both sides. It'd be equal density of redness on one side and equal amount of blackness on the other side. That we wouldn't be able to see this. Hey, there's a side here. There's a black side and there's a red side. You wouldn't see that if it wasn't a magnet. But the same thing is happening. Right now, the gravity goes, most of it goes right through us. And we're not a magnet, so one cheek of our ass isn't red and the other cheek black. You know, we're not filtering the force, but magnets do. And when they're doing that, they're just showing you what charges. They're showing you electron force on one side, proton force on the other side. If I put those two magnets now next to each other, black, red to black, red, the electron force is going to reflect off the black surfaces. The red little bits are going to reflect off the red surfaces. And that's going to create more energy between them because the energy will get trapped. That'll create a high pressure, which will push them apart. And that will perfectly match exactly your experience trying to push two magnets into each other when they have the same poles. You can feel that exact effect. You can feel it get stronger as they get closer because obviously you're forcing more interactions. You're making a more energetic circumstance. You're creating potential energy by attempting to push the magnets together. So you have to use energy to create that potential, that high pressure. All right, higher pressure. All right, so I've been over all that, and I've, I think done a reasonable job explaining it, and it fits. And but I think this has got to be, to have a conversation about fields and force. I mean, first you have to say, okay, we're not going to let Einstein get away with this bent geometry thing. We're going to try to confine the argument and say there's a hidden force. Okay, Einstein's explanation might be right, blah, 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 blah. But whatever bent space is, it's not bent space. It's a force. There's a force out there that looks like bent space. And ironically, Mach gravity looks exactly like bent space. It does. It's, creating a vacuum cleaner is the same thing as making a hole and pushing stuff into it. The two circumstances are identical mathematically. There's no difference. And, as long as you can't lose pressure in the stream. So if you're just talking about making a stream, it doesn't matter whether you pull the cork out or whether you push it from the outside, it'll create the same river, the same amount of current, the same amount of flow. All right, that seems reasonable. So, yeah. All right, nothing from the commenters. Okay. All right, so I don't know what else I need to draw here to make the point. I mean, except beyond just going through this whole magnet thing and this idea of the nature of charge, which is you just have the two things. You have the electrons and you have the protons. And so I guess I might as well just go to the website for this because, I already have it drawn there. I mean, why draw it twice? Yeah, no real point. Why draw it poorly when I can just go with the drawing that's probably more clear? This should be it. Yeah. All right. So that's the overview of the magnet. Now, what I didn't do in this overview is explain or draw. All right. So let me go to the arrows. All right. So you can understand that the protons and the electrons have different rules. The red force goes through the electron. The black force goes through the proton, and vice versa. So the reflections create the high pressure, and the deflections, if you want to call them that, the deflections cause the low pressure. So when an electron is facing a proton, no black force can get trapped because it flies out of the proton, and no red force can get trapped because it flies out of the electron. So you have low pressure, the two things attract. That's the nature of charge. So charge is just a rational consequence of the fact that the electron and proton are changing what's in the field, the kind of force that's in the field. You could say they're not taking force away, they're just saying what kind of force is in there. Well, clearly it is taking it away in the sense of the ping pong paddle example. There's a ping pong ball, and like I said, if I make a rule where the ball's red, and I have a red paddle and a black paddle, you can just get it. The red ball hits the black paddle and it flies off, deflects. It's no longer trapped. It can't do anything. So the field has been evacuated of a force. The force went into some other field, some other directional field, and is now causing high pressure somewhere else. So when it makes low pressure here, it means there has to be a high pressure somewhere else. So that's always the conservation rules of energy. You make something cold one place, you made something hot someplace else. Those are just the rules. And these follow those same rules. So you could argue, I suppose you could argue that this field can be, you can reduce the amount of force in a field and therefore reduce the field. The effectiveness of the field is a real thing because you're basically evacuating it. You're letting it leak out of this space. And the absence of the field is the same as the absence of the force. So I'm just saying the two words sort of have to become synonymous. You can't have a field that isn't force. And all forces are pretty much emanated, in a sense, in fieldy kind of ways. It doesn't really fit with laser beams and all that kind of stuff, so I don't want to get, I don't need to make that rule, so I won't bother with it. But I'm just saying for many things, we understand that it's spherical, that it's like the Earth's gravity, the effect is in all directions, not just one direction. So it does have a, it makes a broad statement. All right, taking this a step further. Okay, so I guess, yes, so this is an argument I've already made, but I'll do it again just because it has to do with this charge thing. And so if you understand the little charge elements, the proton and the electron are filtering force. So in their, like I said, this is a red shirt. If the red thing hits, it bounces off. The black thing hits, it goes in and flies out my armpits or something. It becomes moot as a event between me and you. Okay, it can't affect you now. It went through me, came out sideways. It can't go back at you. But if it's red, it's going back at you. And if you keep throwing red at me, I'm going to keep throwing it back. So you can sort of get that we'll have some tension between us. We'll have an item of force between us that will keep us apart. And if I remove that force, then the force from behind us both is going to shove us together. All right. That's solid enough explanation, I think. All right. Another strange name person. Is it possible that you could sometime think of interesting ways to present how these mechanics build up to simple chemistry? Well, I just, fuck you. Well, look, you know, I don't want to keep saying shit like that. Obviously, if you don't get the ABCs, if you know, we have to build the blocks in the base. Here I'm giving it to you as simple as I can. I'm saying you don't understand what a field is and you don't understand what a force is. You think an ether is some sort of mattress spring or something. I mean, I have to point out how, as long as you have those perceptions, you can't possibly get any of this building with blocks kind of thing, because it's not building with blocks, doesn't have anything to do with vibrating springs and all kinds of other bullshit. So you just can't get any of this. You won't get any of it right, in my opinion. You won't understand Mach gravity. You won't understand any of these concepts. So why would I move on to chemistry when I can't get you to put the A block next to the B block next to the C block? I can't get you to understand ping pong paddles with ball bouncing between them and how it creates more force when I move the paddles closer together. I mean, that's just such an ABC mechanical process. And many of you reject it. Just as you reject the idea that particles can create pressure. and that two things in a field of particles moving in random directions will in fact move right into each other. And it's called mock gravity. It's a fact. People like Bill Gates have no clue what that is. Doesn't even, they never even ran across it anywhere in their travels as a notion. That's the problem, shithead. I mean, I don't need to worry about chemistry right now. I don't need to talk about how actual complex atoms start turning into complex molecules. But it's really kind of just the same process. Attraction created by the absence of pressure. Not too complicated. Or a phenomenon in chemistry. So just like I said, I don't know what to say. I titled the video Force and Fields. It's a really important subject, hugely important. You really can't do physics, no matter what you're going to do in physics or chemistry. Your definition of what a force is and what a field is going to define what kind of picture you can draw. And I'm just saying, if you want to get any of these colors right, you want to have the trees growing up and the roots going down, you want to get it right, you got to get those two words right. Perhaps some quirks in physical chemistry might have something to do down to this level. It's just an insanely silly remark. Clearly, the structural evolution goes the other way around. There won't be anything in the chemistry that explains the foundational blocks. You're not going to learn anything about cement by analyzing the big building. You're going to learn something about it by analyzing the bricks made out of the cement. So, yeah, no. Wrong behavior. Okay. Sorry. Really crappy advice, really crappy suggestion. Thanks, but no thanks. Damn it. Mostly. All right. So back to the drawing board. All right, so we have the proton and the electron. We'll start there, see where we can see how we go. Yes. All right. All right. So so now all they are is filters. Okay, you can just kind of get it. They're just filters. All right, so I just say it over and over again. When red stuff hits the black stuff, it goes out perpendicular. When black stuff hits the red stuff, it goes out perpendicular. So when two red things are in, so you can think of, when you have a mixed environment, that is, you have red stuff and you have black stuff, matter bits, protons and electrons. You can sort of get the idea that these two are going to repel each other. But both of these things are going to be attracted to this fellow because this fellow keeps leaking the red stuff. He keeps letting the ping pong balls fly out. And likewise, any black ones fly out this way, which, prevents the black thing from getting hit by any black ones from this direction. So this black thing is getting hit by black, black, black all the way around it, except coming from this red thing, and except coming from this red thing. And the only way a black thing can get to that is draw black. It's so annoying. Oh, God, I gotta find a way to switch this color. So the only way a black can get to this electron is it has to go this way, and then go this way, and then it bounces back this way, and then it can fly out this way, and then fly out this way. So there's all these rules about path taking, and that's what forms atoms. That's what holds atoms together, is all these pathways that maintain pressure between these individual magnetic bits. So these are essentially the magnetic monopoles, the electrons and protons. They're constantly filtering force. That is, force goes into them, and then they radiate force out of them. So just like the full magnet, they're radiating a particular kind of force depending on what force goes into them. So, we're sort of back to this thing. The little red bits are radiating not a dipole kind of field, but clearly their profile, what's happening in front versus what's happening from behind, or on one side, what they're radiating in any particular dimension is completely dependent on what's in front of them. So if I put another red shirted person in front of me, we're going to have a problem. we're going to move away from each other. But if I put a black shirted person in front of me, we're going to be pushed together. So clearly now it depends. It makes all the difference. So, so we'll get to I suppose the only other the next necessary point to make is understanding. Let's see if I can find some way to do this without the color problem. No, probably not. All right. So I probably should have just drawn it on paper. But the idea would be, all right, so I just draw it and then you can imagine it. I'll presume you're grown up enough to use your imagination. Yeah, that's what I'll do. Well, what I could also do is just do a lot of cut and pasting, maybe. Okay, well, I should have used the square tool because that is just hideous. But fuck it, who cares? Close enough. So I think I might be able to select the whole thing. Yeah, I couldn't select either one. How come? They should be layers. That's interesting. They're unlayered. All right, well, let's see. Sorry, I have to learn how to use this program, obviously. There's some sort of convert to raster. There we go. I only converted one of them. Well, that's just no help at all. I mean, that's just no help at all. Yeah, I wonder why that didn't work. It's very curious. So I put some more red on here. It's probably not going to matter. But anyway, all right, now let's see if I can select that. Yeah, I can. Yeah, it's funny. All right, it's not funny to you. It's funny to me. All right, let's see if I hit control. No, can't grab both of them. This doesn't grab them. What the hell does this do anyway? All right. I just give up on this project. I thought I could just copy and paste, but obviously I can't for some dopey reason. So I won't. All right, but the idea would be is that a magnet is just this over and over again. Okay, so what's really happening is this is an electron and a proton, and they have a bias because they're not spherical. They're not proportional. So there's more proton on one end, more electron on the other end, creates a bias, and I'm just exaggerating. It's not all electron on one end and all proton at the other end, but it is in sort of a way. You can understand that if I had an atom that was made out of if I had a neutron, it's just a proton and an electron. You can sort of understand it's always a magnet. And all you can do is move it in different orientations, but it's always a magnet. It's a dipole. It has both charges. That's why they think it has a neutral charge, is because it's both charges. Whenever it rotates, it's constantly taking away what it gave. So 1 minute it's red shirt, black shirt, red shirt, black shirt, red shirt, black shirt. So that looks like no shirt, but it's really red shirt, black shirt. All right, well, anyway, so a magnet is just basically a bunch of little magnets, that is atoms, that have an ability to be stacked. Man, that is just some really bad drawing. All right. Probably should get a tablet one of these days, someday. I had an old one, but I don't know if it'll work in Linux. I guess I could try. Well, the pen didn't work, though. Well, I'll think about it. All right, so a magnet's just doing this, plus, minus, plus, minus, plus, minus. It's just doing north, south, north, south, north, south. Then they're stacked. And the idea is where the line is of their stack. Where you decide this is a magnet, this section, or whether you think, no, this is the magnet here. Where's the line that defines the magnet? Because if it's this way, then it's north-south. And if it's this way, it's south-north, obviously. But they have a configuration. And so when they're stacked in the real world, what's really going to happen is that they're going to line up next to each other, right? Because of this attractive idea. Because all the force disappears between the black thing and the red thing. No force. So these two are going to get lined up this way. And so this magnet will be out of phase, so to speak, with this magnet. So you can see that. So if this was the alignment of the magnet, this was the solid little magnet, the first magnet. You can see this magnet could be formed. Got to find a way to switch the color without all this bullshit. Okay, so you can sort of get the idea. All right, that they're going to line up out of phase. Okay, and so they'll be very close together, and they'll all, in a sense, so you'll see that the end of the magnet, you can already see it starting to happen here, right? But if I keep doing that, the end surfaces, you're going to see, are always turning all red. So from this perspective, right, whoops, this is all red. And from this top perspective, it's going to be all black. It's sort of defining the nature of this magnetism thing. And likewise, when you approach the magnet with force, there's going to be a high probability of whether the magnet at one end is pointing all in one direction. So it's all, the movement of the, okay, movement's the wrong word. All right, I don't know exactly how to say it, but the probability of let's see, I have to think of another way to say it. The alignment. So again, just think of it. Okay, so what I could do is a trick to illustrate the side view. See, the real details are always a little bit subtly different than what you can easily explain, and so you'll take little cheats to sort of explain it. But you can sort of understand that I could make this black here, and I could make this black here. Okay, because I have free electrons, and this is where the free electrons would go. So now, if I look at this surface, it's all black. So anything black coming in here is going to reflect. And anything red coming in here is going to shoot out perpendicularly. And perpendicular in this case is going to be coming out of the red end of the magnet. But anyway, so that's the building blocks. Those are the obvious building block of a magnet, is just arranging the atoms and the electrons. The electrons also get arranged and create a surface. And the surface is basically doing the filtering for you. You can sort of see how the mechanics of the magnet create that surface. And that's sort of going back to the original point being made about the two conductors. Well, I guess I suppose I should have drawn them. Well, you can just do it with an X and a Y. You have two conductors going into the paper and coming out, the two wires. And the fact that they create either an attractive field or a repulsive field. And the fact is that the opposite way should be attractive if they were magnets, but it's not with DC current again. That's the point where we started. But again, but you have to understand that what we do know about these conductors is that the electrons are on the surface, and the surface electrons are the things carrying the current. Okay, so it's basically the electricity moving through the wire, right? So if this was the wire, the electricity moving through the wire is changing the red blackness of inside this wire, so to speak. So okay, this is probably not a good way for me to illustrate it because I'm using black on the inside. Now I'm going to put red on the outside, but it really doesn't matter. Shouldn't matter to you too much. But what ends up happening when you start putting current through the wire is that you're segregating the shape of these atoms, and by shape changes, you're creating a filter. And so now the wire itself becomes a filter. It will reflect, when the force comes in, it will reflect it back and forth, and it will behave like a magnet because you put charge into it. And depending on how again, these are the ping pong paddles of the charge. So once you're moving charges, You have to recognize that that force is going to be moving in a direction now. It's not just going to be reflecting, it's going to be pushed. And that makes a difference. All right, but that's a little subtle and a little complicated, so I don't think I'll go into that any further. All right, so this is probably good enough. So we'll see if there's any reasonable comments and any reasonable interaction, and that'll be it. Your monetization enable or not. Now, I don't monetize the videos. You can always donate on the website. They did put a commercial on the last video because I had the little Speed Racer clip in there. So they did, YouTube tells me, basically forces me to accept their fair use interpretation, which is I don't have any fair use rights until I go out and argue for them. And so I have to do the work to get my fair use rights. I shouldn't have to go to court to get fair use rights. I have the assumption of fair use rights. It's supposed to work the other way around. The person defending their copyright is the one who's supposed to do the work, not the person defending their fair use rights. So the whole thing is preposterously illegal, and they get away with it because nobody does anything about it, because everybody's fucking civilization dick is totally inverted and skanky and disgusting, and people can't think rationally about what civilization is supposed to look like. It's not supposed to be run by billionaire companies trying to take advantage of retards, trying to molest retards. That's a social commentary. We'll save that for some other time. All right, so I think I have done a fairly good job of explaining this whole field force thing. There's no field until you put a force in it. There's no photons until you put the photons. Do you make some photons? There's no photons. And it's true for every other field. There's no field till something's in it. And the only field that's always full is gravity. That's the one that always has bits moving the speed of light. And you can filter them for charge, or you can release them at a frequency and create a photon, what we call a photon. Electromagnetic radiation that has nothing to do with electricity or magnetism. It's just radiation at a frequency. And once you break it down to this, like I said, make it this simple, it fits everything. Fits all the evidence very well. The model works. It explains where the energy comes from, which is fucking huge as a fact. That's like getting a perfect 1 in 200 billion genetic match. I mean, it's a huge piece of evidence that this is the right answer, because it explains where the energy comes from. All right, I want to break down the Veritasium video about LIGO. Why would I do that? Isn't his video titled something stupid like, could there be gravity waves? Or it's some sort of, it's almost like he has a sarcastic title. Isn't that too fantastic or something? And then he's actually defending it, which is funny. So I don't even know if, give me the title of the fucking video at least. No offense, but you might have more than one fucking goddamn video on the subject of LIGO. But there's no point. I've already broken it down. I've already made the points I can make. I can just say there's no theoretical grounding for converting matter into bent space. Bent space is not supposed to be radiation. It's not supposed to be a force. How can you possibly convert matter into something that's not a force and it's not energy? How can you do that? How does that make any sense? Yeah, so the title is The Absurdity of Detecting Gravitational Waves, and the video is basically an endorsement of it. So that's the bizarre part. He's implying that it is absurd, and it is, and yet we did it. But it's absurd, okay? You can't do it. except by creating some false, huge energy source that magically doesn't affect anything else in the universe. So anything within a light year or two of the source of this wave wasn't affected at all somehow, and yet it shook the earth. I mean, it's just absolute. It's a mathematical pile of crap. The math can't possibly work, and it only possibly works because they did something that Einstein would never. And they keep pasting Einstein's name on this shit. Einstein never would endorse some notion that you can convert matter into bent space. It's just silly. He never even speculated about such a thing. Absolute crap. Einstein said clearly, you'll never detect anything like a gravity wave because gravity diminishes in strength. You'll never see a light bulb from 1 billion light years away. This light in my house, there's no photons. There's just none, okay, that are getting to Alpha Centauri. It just isn't going to goddamn happen. And such. So probably around Thursday or Friday, something like that, I'll probably do an Emendum room with Mr. N.S. Courage. What are you, named after a boat or something? Maybe he is a pirate too. Lots of pirates out there. Doesn't sound like a pirate though. Does have kind of a goofy icon, I have to say. But, you know, lots of goofy icons out there. And such. All right, so again, so this all goes back to my argument that there's just these little subtle things that would help in when people are trying to have this conversation and recognizing that there's a concept called the speed of force, not the speed of light. Huge conceptual improvement in terms of having a conversation. Recognizing that light is just one of the forces moving the speed of light. That there's lots of radiations out there that are moving that same speed that we can't see with our eyes. And gravity is one of them. It's moving exactly the same speed. And all we're really saying is, yeah, you can't see it with your eyes. You can watch it move shit. See, this moves just like if I pushed it with a very strong invisible laser, right? I mean, it's doing exactly what a big, strong laser would make it do, right? It's really no difference. And magnets are doing the same thing. There's a real force, real energy, moving, pushing, affecting. Not little wimpy, wavy crap. So I'm pretty damn sure I have a video, if you look it up on my channel, called Veritasium on LIGO. I probably already played his video. But I don't mind doing it again, just to point out the same 10 things that never get answered. And now that I have even more information on how flawed interferometry is as a theoretical concept, the very idea of making a beam splitter, they have a theoretical problem making one of these things. It's not easy to create two equal beams. Is to create two equal beams, to split them, you fundamentally have to do something that has fundamentally a different energy profile to the two things. One of them is getting affected, one of them you could argue is not. It's always going to require that kind of, you're right-handing one and you're left-handing the other. And that's a real problem with it theoretically. You really can't create two equal beings. They're going to be different. And then you have the third problem I brought up, which is based on quantum mechanics, as it's badgered into our brains, this phenomenon of random Heisenbergian wave function interference, this wave function is supposed to be something that happens just to one photon. It creates wave function. And the wave function roll dice, and then the result is achieved. So Feynman thinks, yes, there's no wave, there's just rolling dice. He thinks the universe does roll dice pretty explicitly, and that it's doing it on the photon level. The photon's rolling the dice. He doesn't think the matter's doing it. He thinks the photon rolls a dice, and the dice roll decides what happens to the photon. But clearly the interferometer is you're basically arguing that no, it's two separate photons. One takes the left path, one takes the path, they take the separate path, they go through the device, and then somehow they interfere with each other after they went through the device. Somehow their independent wave functions interfere. Pen interferes with, marker, and you end up with a result. No dice roll, some sort of physical interaction between two different photons. So what is it, quantum mechanics people? What is the real rule? Do single photons interfere with themselves, or do different photons interfere with each other? Answer the question, please. I mean, if you're going to tell me you've done something, and you're going to tell me that it's a kind of a miraculous, extraordinary claim you're making, you can't answer that simple question about your device and how it works? Come on. You're obligated to answer the question, or quit talking about your UFOs. I mean, you got to put up, or you got to shut up. So anyway, it's a change of subject, which is a little bit annoying, but it's sort of related. Obviously, gravity is the biggest field there is, and the one, as I'm arguing, all the other forces, all the other fields are just filtered gravity. I can't keep up. I keep interrupting comments with other comments. I'll start with, I'm excited for the stream. Okay, well, that's a separate subject, but fine. Try to stay physicsy here. Physics. Fields and force. So anyway, yeah, so I would like to find people who are willing to have a room to discuss physics. And I think it would be rational to limit the room to, say, 3 participants. Would be nice. That'd be an ideal number, I think, just to have that third person to kind of keep it more honest. The fourth person would probably be a distraction. Like I said, it's hard to know what the right number would be, but as soon as you get too many people in a conversation, the conversation turns to shit. So you always have to be careful about not having too many, and obviously too few, not too good. So there isn't a best number. And so it's almost like, I mean, I hate to even say it, but it might be interesting to do a Hofladay, Piro, and me room or something like that. Be interesting to get, 3 very different opinions and see if we can agree to some language, some foundation of language. What language are we going to talk in? Are we going to speak English? Going to speak Portuguese? Going to speak Spanish? Going to speak, we have to establish a language of discussion, or the discussion isn't going to go anywhere because somebody's going to keep asserting that an ether is made out of, rubber bands or something. And they're just going to keep asserting it, and you're going to keep saying, no, it isn't. Not in my brain, it isn't. Why are you saying I have to make my ether out of rubber bands? I don't have to do that. I can make it out of lots of different stuff. I don't need to make an ether out of water molecules that are sticking to each other. I don't have to make an ether out of sticky stuff. All right. If photons could interfere with themselves, why don't they do that all the time? Well, that's sort of the Heisenbergian rule, is they apparently only acquire this problem when they are being, when you're trying to pull their pants down, when you're forcing them through a circumstance that will allow you to see where they are and how fast they're going. So if a circumstance starts to give you information about exactly how fast they're going and where they're pointed, well, they don't like that, and they decide to press the invisibility button. Press the roll the dice button. Press the I'm turning into a wavicle button. It's some kind of crap like that. But yes, it's a nice sarcastic experiment because yes, it's why don't two laser beams, reflect off of each other? Why, when I mix a red laser with a green laser, why don't I get to do, another color? Why do photons never interact with anything ever in every appearance? If they're bent by gravity, why aren't they bent by magnetism? Clearly, magnetism is the much stronger force. So how can they be bent by gravity and not be bent by magnetism? Come on. When they're electromagnetic. Doesn't make much sense. So, like I said, there just are some just glaringly huge flaw. And the fundamental first flaw, we all should be able to agree on the first flaw. Even the defenders of quantum mechanics and relativity should be able to just concede this not having energy doesn't look good. That bent space would be a lot more reasonable if you didn't have to rely on some slopey vision of things falling into wells, or the silly notion of an infinite drain with an infinite source of river water. It would be a lot better if you had something called energy in your system. And clearly, the quantum mechanic people should be able to concede that virtual photon, making up an invisible photon, photon that isn't real, merely because you can't account for where it came from. Because you can't say a real photon, because then you have to explain where did the real photon come from. Because that takes energy. A sun has to burn to create those photons. So you'd have to explain what's burning inside the magnet. Who's shoveling coal into the magnet to make the photons? And and even the quantum mechanic defender should be able to admit, okay, yeah, there is a foundational problem there. We think we think the fact that we found a cell phone that has a UFO's signature on it, that's proof enough that there's UFOs. So we're comfortable with our theory that we've discovered UFOs. So we really don't need to know that there's no battery in the phone. How can you make calls with no battery? Whatever, something like that, analogizing. I'm just saying they should be willing to concede that their theory would be better if they didn't have to say virtual photon. But yeah, that does kind of make it sound silly. Comes down to, does LIGO, you're changing the subject some more, meaningfully measure a delay in points in space being affected? Now, the delay is irrelevant. It's the speed of light. Gravity waves move the same speed as light. There's no delay in any meaningful way. It's just force moving. So that's a meaningless point. What to make it meaningful? What did make it meaningful? I don't even know what that question, I don't even know. Obviously saying to me it doesn't mean shit. And to me, it just means that it's an obviously contrived event. It can't possibly happen the way they theorize it happened. Their device can't work the way they theorize, and gravity doesn't work the way they theorize. So the whole thing is made out of shit. They still haven't even explained how the two black holes started doing this binary crash into each other thing, because even that's not there's not too many reasonable ways to come up with a way where two black holes don't crash right into each other right from the beginning. It's very hard to put two black holes into an orbit unless you create them in an orbit. Unless you create them out of something that was one thing and you break them apart, you have very little odds of having two very massive objects not just crash. There's no way to put them in orbit. You can't even put the Earth in its orbit, okay? Theoretically, without it hitting something. You can't orbits are really hard to manufacture. And these are really smart people, and they seem to just totally ignore that fact. And that is fucking a little bit scary also. Is the interpreted distance long enough? Okay, more of this nonsense. What else could interfere with results? I mean, this is just, I don't know what you're talking about. What results? They're listening to the universe, to sounds that might only happen one every 10,000 years, sounds that could happen once every 1,000 years, sounds that could happen once every 100 years. Could they possibly know what those sounds sound like? Have you recorded every fart you ever made so that you have a whole record of every possible fart you've made? And therefore, you know when you heard, oh, that's one of my farts. I mean, that's what they're doing. And it's just on its face a bold assertion that they somehow have filtered out all the possible Earth sounds. Yeah. No, they haven't. All right. But, you're really annoying me. LIGO is not the subject of this video. LIGO is it's a marginally, like I said, I'm saying theoretically, it's not even marginal. It's all right. I'm not going to say it's junk science, but it's really close to junk science. I mean, it's pseudoscience. It's so theoretical. It's so unproven. It's really not worth much of a conversation because the proof is so bad. Okay. What could be sensibly or insensibly be interpreted as a force or an inverted force? I mean, what the fuck are you talking about? There's no inverted force. I mean, I explained it pretty clearly. All right? The red things are real. The black things are real, the little force bits. And the difference is the red ones reflect off of red, and the black ones reflect off of black. And if they hit the opposite color, they're diverted. What can't you understand about that? I have two ping pong paddles, right? Now, if the ball is bouncing back and forth nice and routinely, it's fine. But if the ball bounces at some weird angle and flies out between the two paddles, well, then there's no force between the paddles, right? There's nothing inverted. There's no inverted force. What the fuck are you talking about? Man. Pushing with ropes? What are you even, where are you? Where are you? What are you talking about? See, you just, I thought this guy was smart. I mean, I don't know how you could take this video and pervert it into questions or comments like that. I just don't know where you're going with this shit. I mean, I sit there and meticulously put, look, X, 0, red, black, simple, not complicated. Filter. The filter makes the red stuff go one way, the black stuff go another way. I mean, I don't know. I just don't know how you can make this complicated. I just don't know. Black and red forces going in, all random, all mixed up. The magnet, because of the arrangement of the atoms, disproportionately causes black things to go left and red things to go right, kind of a thing. And because of that, now you can trap more things between the red paddles on one side, and you trap more things between black paddles on the other side. You can create more pressure between electrons on one side and more pressure between protons on the other side. You change the universe, for fuck's sake. That's what forces do. They change the environment. They create more pressure on the outside, or they create more pressure on the inside. They make things expand, or they make things contract. I mean, expansion and contraction is a nicer way to say attraction and repulsion, right? I mean, expansion and contraction is pretty easy to understand, and it's not a biased thing. It's not like I love you versus I hate you. I mean, it just makes you understand that, yeah, that's an obvious yin and yang. One isn't better than the other. They're just reciprocals of each other. You make one out of the other. I mean, it's just, so when you're compressing, you're creating potential energy, more bounces. And when you're expanding, you're, obviously you had to use energy to expand because the external pressure is always hitting. To go out into the field means you're going out into the gravity. So you can have the electricity in little things, creating little environments where you're protected from the external world, so to speak, by being pressurized. But if you expand into that real world, the only way you can expand is you have to create high pressure to expand. You can't move into the space without having the pressure to do it. You have to force yourself. You have to be forced in, and once you're in, you have to force your way out. Force is the only way to move. Force is the only way to move. Yeah, I mean, that's just too easy. Okay. LIGO equals red herring, I meant. Well, you didn't. These points you're making didn't sound like red herring. I don't know if it's a red herring is the right word to use. Clearly, they're not using it as a red herring. They're not trying to distract us. They're obviously quite invested in obviously the people who promoted the propaganda got well paid. All right. So the people who are part of the industry of gravitational waves did very well. Nobel Prizes and big bucks. Now, why the rest of science, the rest of physics, why did they endorse it? Well, I guess it just might be because later they want the LIGO people to endorse their Hadron Collider. Yeah. And then they'll win big money and big prizes. So, they're all just kissing, they're all fondling each other's propaganda, however you want to put it. But yeah, it does seem like a bunch of self-interested douchebags just duping an ignorant public that has no clue what's going on. And they're just saying, they have a pocket pouch, with pens in it. They must be smart. So I have glasses and such. I just trust them. They know what they're doing. When all they're doing is counting their money. All right. No, I'm not smart. Well, okay. I get it. Well, that's good. Slant turns to tendency. Slant turns to tendency. Yeah, well, whatever. Whatever. The problem with bias is, frankly, it's part of the rational process of drawing conclusions. You can't just stay unbiased forever. So somebody might fool you for a while and say, trees are alive and they can walk. All right. So for a while, you'll give it the benefit of the doubt. You say, okay, well, maybe when I'm not looking, they're walking around. I haven't really, I didn't take pictures of where the tree exactly was. Maybe he moved a little bit. So, for a little while, you can be fooled. And then you say, there's a certain point where you say, no, I got to just draw a conclusion. The conclusion is trees don't walk around. Fuck that. That's nonsense. So there's a point where you have to end being unbiased, and you have to bias. So it's just really about what's the rational standard for where you become biased, where you become a fanatic. And I would argue that physics looks like religion in the sense that they've lost their bias way too soon. I mean, they've closed the door to any other possible God. They won't even listen to another religion, let alone listen to a scientist talk about evolution. They're so tied and slutted to their wavical notions, their Heisenberg and their Huygens and their many universes and their uncertainty principles and their waving blah 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 non-mechanical universe. They're God playing dice. For some reason, they like the God playing dice answer to reality. So, as I've suggested before, if you are a viewer of some curiosity, you can email me at ds@raftphysics.com if you would be willing to participate in live conversation, going over points similar to the ones gone over in this video. Subjects in this related to relativity and quantum mechanics, and how they're not really particle theories in any way whatsoever, and they're basically just magical theories of function. Most of the forces are magical. So I'll give you a couple more minutes, I suppose, 2-minute warning or something, participants. And I think a Sunday afternoon, Sunday morning in California. You'd think there'd be somebody willing to play physics, but just very low participation numbers, probably 12 again. Yeah, it's the same number every time, 12, 12, 12, 12, 12, 12. Yeah, just not good enough, unfortunately. Not close. So, yeah, let's see, smoke some more. And then I'll give up. I think I've said enough. I could just keep redundantly going over stuff, but I don't know, it's no fun. But this image of magnets really needs to be understood. It looks just like a checkerboard, right? Yeah, it's checkerboard. It's really that easy. Checkerboard. That's all it is. Checkerboard. And such. I probably did cheat a little. Like I said, this added these electrons connected to these protons to make a black surface would actually work on both sides of the magnet. So that really doesn't, that's really not a good enough explanation of the difference between the, how the force, I wish I could do that. I mean, we should just change colors properly. I wish I just got to find it. God, there's got to be a way to do this. Got to be a way to switch colors without this bullshit. So, but the idea is that the force does radiate. And what the radiation is, though, so you have to understand that something can look like it's radiating out, okay, of something, but it really just went through something. And the idea is that the black comes in here and it ends up coming out here. So it ends up being deflected perpendicularly. just like with the proton perpendicularly moves the force, and the red force is perpendicularly moving out of the black. And the other way to look at it is that any black force that actually did come in this way never went through the magnet. It just reflected off the magnet. So any black that comes in reflects, which looks the same as radiating. So you could argue that a light bulb, if there was invisible light, that was going into the light bulb, and you only get to see the stuff that reflects. Yeah. But that's what it can look the same, is all I'm trying to get to. A force going right through looks the same as a force reflecting off the surface. You wouldn't be able to tell the difference between those two things. And so that's really what's causing the effect. But I didn't want to get into that kind of detail. But it's an important fact. And it's not, obviously, magnets aren't reflecting all of the force in this manner. So they're not a perfect filter until you start getting them super cooled. And then you start increasing the efficiency of this effect, this filtering effect. All right. But there's no current inside this magnet. So that's the other part of the conversation those people are having, is this idea that you need a current. That is, you need to be moving charges to create magnetism. And obviously a static magnet there's no evidence of anything moving in here, anything energetic in here. It seems pretty clear to me, and it seems the evidence kind of indicates that this thing doesn't have any energy in it, and that somehow it's just converting the energy it's exposed to, and it's not really converting it in an uneven way, because it's giving you back exactly what you put into it. It's just giving it back to you, in a new form. I mean, in a new shape. It isn't changing its fundamental character. It's just changing the fact that it throws one thing one way and it throws the other way. It would have to throw it no matter what. It's going to have to deal with the force coming in. It's just dealing with it in the sense that it's accidentally filtering it, segregating it, which magnifies its potential effect. All right, so that was an important little extra bit, I think. All right, the benefit of the doubt. I hate that phrase. But anyway, well, I don't hate it, but yeah, I don't like it. My curse and my blessing, yes. I, as an amateur, would like to participate in a physics room as well. Yeah, I'll give you that chance. I do know math beyond adding, subtracting, dividing, and multiplying. Well, I mean, but you probably understand the mathematics of, say, Pythagoras or something. You've probably heard of pi, okay, and you kind of understand that there's a relationship between radiuses of circles and spheres and the circumference and area of those things. So you probably do a little bit more. Isn't it the case that different metals, have their magnetic properties at different points of temperature? Yeah, well, I really don't want to go into all that crap, but obviously the chemistry decides how well the atoms can arrange. And clearly, the more noise in the system, the less your checkerboard's going to look like a checkerboard, right? I mean, if I have all of these little black and red things, and then I put a bunch of little balls between them, ping pong balls, right? They're paddles. The red and the black things are all paddles. And so if I have a system that has a bunch of already has ping pong balls in it, well, I can't get my red and black things very close because there's always going to be balls bouncing around in there, and they're all going to be jiggling all over the place. So my board isn't going to be very coherent. So yeah, the cooler, the more solid the board gets, the more coherent the board gets. Yeah, okay, so we did that. Oh, another hi person. Hi, I'm afraid of donuts. Gee, that's just so not terribly interesting. Oh, foreigners. Joao. Retardo. I mean, I hate to admit it, but you could just take most of the world and all their languages and all their countries, and you could just ship it off to Mars or something. I wouldn't miss them at all. It's just a fact. No, if I could, in some way contribute to a plan to, take most of the people on Earth and send them off someplace, yeah, I'd pay for their ticket. I don't have any use for them. Joaoga, I don't have any use for. Not very useful. The truth is, I'm probably even worse than this because I probably would vote for, grinding them up into cat food or something. I probably would also vote for a secret plan not to take them to Mars, but just dump them in space. Yeah, I really got no use for diversity, and I'd love a planet just made of me. Gary and Gary. One has a penis and one has a vagina. And yeah, fine. All win for me. But that's a separate subject. Just a matter of personal taste. No offense meant. Unless you're some foreign turd bag who makes fucking erroneous crap comments on videos. Unless you're one of those people, you could take offense then. I'd fix language first and see from there. Yes, well, it's definitely we need to have a way of communicating with a language that has reliable words in it. And, even there's a whole bunch of people who speak English, but unfortunately it's not the same English. They think waves go in straight lines and shit. And you're like, waves don't do that. Waves aren't a coaxial cable. I don't call it a wave cable. No, that's retarded. No. So yeah, I mean, there's this huge problem with these words that don't mean anything. Yeah, huge problem. Giant. But even all these words, these adjectives and adverbs, and you got all these nice words to kind of say things. And I could say the word "huge problem," and to some person that means nail. Nothing. And somebody else takes huge problem to mean catastrophe. You can't fix it, unresolvable, blah blah blah. So it's like you can't get this emphasis right. You can't get the there's just no accuracy or depth to conversation. It's all inaccurate and putridly simplistic. Two meanings of reality. I don't know what you mean by that. Reality. Oh, okay, yes, you can be a realtor or you can be a realitist. Yeah. I mean, yes, even the spelling problems are horrible. But I don't know what you mean, two meanings of reality being a glaring one. I don't know what that means. I only have one definition of reality, so that one's easy for me. I mean, the whole being a dualist of any kind, thinking more than one statement, thinking that conflicting or contradicting statements can be true, that's just retarded. Yeah, we just have too many words saying the same thing. It's like two meanings, right? So you got two is kind of explicit. Okay, we get that too. The word meaning. Now, meaning can just be, why bother with this extra word, meaning? Why don't we just say definition? You know, I mean, isn't a meaning just a description, a theory, of fact? So it's just a description. So two descriptions of reality being a glaring one. Yeah, see, that could be a good statement, but you just need to put in there two contradicting definitions of reality being a glaring one. But see, that's where if we had a good language, then we would say things precisely like that instead of imprecisely. When a fist comes flying at you, shit's getting real. Well, again, reality doesn't have anything to do with how physical reality gets. To me, it's a description we're talking about. And you can have highly accurate, precise description, or highly suspect and imprecise description. And clearly one is more preferable than the other. But the key thing is wrong is what you're always looking to avoid. You just don't want to have a wrong general description, and you don't want to have a wrong specific description. You want to avoid making mistakes, errors. But I think it's just as real theoretical understandings of mechanisms is in many ways more real than visceral smell your poo kind of bullshit. Visceral punchy stuff or something has nothing to do with getting real. Getting real is understanding that you can't wish poverty away. You can't wish or hope. I hope I'm not going to die. Yeah, well, fuck you. You're an idiot. I intentionally didn't say the two meanings definition. I don't know what that means, but fine, okay, whatever. I intentionally didn't say the two meanings definitions. I don't know what that means. So it's not like you have to have the two. There's not the two. There's numerous fucked up definitions. The real point is that any two you choose to compare can't have contradiction in them. So I don't even accept your so let's play the anal game. Okay, we're just going to do anal word minutia. So now he's titled it the two meanings, as if there's only two meanings, two definitions of reality, when of course there's 7 billion definitions of reality. And those are the ones that are actively participating at the moment. There clearly is a whole bunch more, if you count all the ones from the past. And the real point is that clearly there's no point in these interactions with these different ideas if these different ideas can presumably coexist as truth, because they are missing the elements necessary to be truth, in that they're contradicting each other. That's the first rule you can't break. Up isn't down. All right, I guess that's about it. Kind of straight off the subject, and there really isn't, not that the NS Courage guy isn't a decent ship of shape, but yeah, it's just not enough boating. We need some more boats in the water here. So anyway, yeah, for this one person talking to typers, you definitely need more people. More people, the better, because you can just ignore people really easily. But yeah, live conversation, the fewer people, the better. Just the two opposite, two different rules, or two different types of communication. But anyway, so if anybody else is out there needs to say something, say it now. Because the window is a closing. Oh, 10 viewers. That's terrible. Almost down to single digits. Oh, the humanities. What an indignity. But it's the price you pay for being a good guy in a world full of shit. Yeah. Letting your white hat clash with all the black hatters. So anyway, till next time, and such and so forth and whatnot. So I think we will go this time. Don't see anything happening. Let's see. Because of those 7 billion definitions, I did not say two definitions. Again, you can keep saying it. This is about not two different. I don't care. I didn't. You didn't say the word the. You did say the word two. That's sort of important. I mean, I didn't say two. You said two. Not me. You. All right. So till next time and such.